All right, before we get started, this is a quick warm-up exercise which I think will help you understand the main concept in this section. And you definitely do this yourself. It should be nothing too fancy going on here. I just want you to check if each value of x, these are the values of x I'm giving you, is a solution of that equation. So for part A, just plug in each of these ones and see if it makes the equation work. For part B, plug in each of these ones and see if it makes that equation work. It'll take you a couple minutes, so pause it here and I'll show you the answers so you can check in a minute. Okay, so if I plug in x equals -2 into this first one, this is going to look like -2 minus 2 times 3 times -2. Well, let's just turn that into -6 plus 4. We want to know, is that equal to 0? And if you work this out, you'll get -4 times -2, which will give you 8 is equal to 0. So no, that doesn't work. Then if you plug in x equals 2 here, that's going to give you 2 minus 2 times 3 times 2 plus 4 is going to be 6 plus 4 is 10. Is that equal to 0? Well, yeah, if you do, this is going to become 0 times 10. And 0 times anything is definitely 0. So yeah, x equals 2 is a solution. That's one of them. Let's try this one. X equals -4/3. I think I need some more paper here. So with x equals -4/3, I'll try this one over here, I guess. So that will give you -4/3 minus 2, which I don't even know what that is. It's going to be some weird fraction. And then we're going to do 3 times -4/3 here. 3. And that plus 4. We want to know, is that equal to 0? And we're going to get some weird fraction for that -4/3 minus 2, whatever that came out to be. And the 3 times something divided by 3, that just cancels out, and you get -4 plus 4. Is that equal to 0? -4 plus 4 is equal to 0, so this whole thing becomes something times 0. Whatever this weird fraction is times 0 is 0. So yes, that is a solution. And then if you plug in the -3/4 into that, I'm going to save you a little bit of boring time watching this. Here is all of that work with the fractions. When you do the 3 times -3/4, the 3 is really 3 over 1 here, if you think of it that way. And so you do 3 times -3, it gives you that -9. And then if you want to combine these into one fraction, you need to write them with the same denominator, which is going to be 4. So I rewrote this 4 as 16 divided by 4. And then you can do the -9 plus 16 to get 7 here. And then the moral of the story is these two numbers are not 0, and if you take any two numbers that are not 0 and multiply them together, you're going to get something that is also not 0. So that's not a solution. All right, that's that one. Now for part B here, let's see. If you plug in 3 into this, you see this is going to make this factor equal to 6. So let's just check if that is actually a solution. So, oh yeah, it does make one of these factors 6, but the whole thing becomes 6 times, 3 minus 4 is -1. Oh, so that doesn't work. So the problem is if you make one of the factors 6, but then the other one isn't just 1, then you're going to get something that's not true. So x equals 3 is not a solution. If you plug in 4 into this, 4 will make one of these factors 0, but that doesn't help because you get 7 times 0 is 0, and 0 is not 6. So it's not a solution. If you plug in 10, that will make this one, the x minus 4 part will become 6. But let's see, that's going to look like 10 plus 3 times 10 minus 4. Is that equal to 6? That gives you 13 times 6 is not equal to 6. So, yeah, 13 times 6 is not 6, so no, none of these are solutions. So, yeah. All of this is leading up to the zero factor principle to help understand this, which is that the product of two factors is equal to 0 if and only if one or both of the factors is 0. So the factors here are A and B. Those factors are like the things like x minus 2 and 3x plus 4. And if you want to make that 0, one of these or the other, or maybe both, would have to be 0. But it doesn't say anything about when you have 6 on the other side. It's just called the zero factor principle, not the 6 factor principle or anything like that. That's a common mistake, is to look at equations like this and think that x equals 3 or x equals 10 would be solutions of that, but they're not, as we can see. Here's an exercise we're going to do. This is one you should try yourself, but I'm going to do it too. So to solve this equation means to find what values of x makes it work, and according to the zero factor principle, a value of x that makes one of these factors here, there's the factor x minus 6 and the factor x plus 2. Those are the two things that are being multiplied there. So what we want to do is see what values of x makes either one of those equal to 0. And so you can add 6 to both sides of this, so you can see that x equals 6 is what will make that first factor 0, so that will be a solution. And with this one, just subtract 2 from both sides, and you see that x equals -2 is what will make the second factor 0. So this has two solutions, two values of x that make this work. Now what does that have to do with the x-intercepts of the graph of this? Well, the x-intercepts, again, a reminder for that, x-intercepts are points on the x-axis, and as we know, points on the x-axis have the y-coordinate equal to 0. So to see what x makes that y-coordinate 0, that should, we're just going to plug in y equals 0 into it. And we get that. And now we need to solve this, but to use the zero factor principle, we got to factor it first. So here we're going to have x plus something, maybe x minus something here, and whatever these numbers are here, they need to multiply to make -12 and add up to -4. Oh, and I think I see some inspiration over here. -6 and plus 2 should work. If you check that by foiling it, you do x times x will give you x squared. -6x plus 2x adds up to -4x. -6 times +2 is your 12. So that looks good. Now we can say, now to solve this, to find the x's that make it work, well, we've already done that. If do we want to make x minus 6 equal to 0, that would be x equals 6. And to make this one equal to 0, we're going to say x is -2. Remember that when you're talking about the x-intercepts, we're really talking about points on the graph. That these answers aren't just numbers, it's more like the point 6, 0, which would be over here. So that's 1 point on the graph, and then -2, 0, because the y must be 0 on the x-axis here. That's another point on this graph. So I don't know anything about the rest of the points on the graph of y equals x squared, -4x, -12, but at least I know these 2 points. The rest of the graph is going to be some kind of parabola, either going like that, or maybe going to a peak and then back down. So that's the end of this video. In the next one, we'll look at some techniques for solving equations that are trickier and more complicated than this, and also compare it with the extraction of roots from 3.1.